Okay, this is going to be the second video for Note 61, and it's going to be all about question number 3, which is graphing a quadratic. So there's a whole bunch of key features I want to find here. And remember, we've done this first semester, but if you forgot, we're going to go through all the bits, parts, and pieces. So I'm going to start with finding the axis symmetry first. So how do I find an axis symmetry? Well, that is going to be x is equal to the opposite of b over 2a. So for the particular equation that we have, it's going to be x is equal to the opposite of b is negative, b itself is 1. So that's going to be negative 1. And then 2 times a is also 1. So that's going to turn into negative 1/2. So your axis symmetry is going to be x is equal to negative 1/2. I'm going to go ahead and put a little box around it so I can find it. There we go. Okay. So now, what does that tell us? We've got an axis symmetry, so that's where the graph, folds in half. But that also tells you half of your vertex. Specifically, it tells you the x value of the vertex. All right, so what we're going to need to do is figure out what y equals when, whoops, forgot the equal sign, when x is equal to negative 1/2. All right, so I'm replacing all of the x's in the original problem with negative 1/2. So this is going to get a little bit weird, but let's see, negative 1/2 squared, I'm going to take the numerator and square it. So negative 1 squared is 1. I'm going to take the denominator and square it. So 2 squared is 4, so that turns into 1/4. Plus a negative 1/2 is really just minus 1/2, and then minus 12. Shockingly, I did not give myself enough space to move and to write, so let me slide that over. There we go. Okay. So let's see what we got here. 1/4 minus 1/2. Let me go ahead and convert those into common denominators. So that's going to become a 4 there. So 2/4. So negative 1/4 minus 1/12, which is going to be, actually, let me convert the 12 as well. Put that as a denominator of 4. So 48. Whoops, why did I highlight that? I meant to erase it. All right, so everything's out of fourths now. So negative 1, negative 47, no, negative 49 over 4. That's what I'm looking for. Not quite awake. Okay. So negative 49 over 4. Yeah, that's terribly helpful. Negative 49 over 4. If you know how to convert to decimals, or if you grab a calculator quickly, this would be negative 0.5 and then negative 12.25. Let me double check that. So let's see here. I grabbed a calculator, and I'm just typing in very quickly just to make sure I didn't screw anything up. And if you are currently yelling at the computer that you screwed it up, I did not. Okay, go me. I can math today. Okay. Now, as far as the answer goes, I do have a preference to the fractional answer. However, knowing that I'm going to need to graph this eventually, negative 49 over 4 and trying to graph it, not so much. But negative 12.25, I can at least estimate that. All right, let's see if the zeros are going to be easier to find than that vertex was. Ew. Okay, so for the zeros, which are your x-intercepts, you are going to set y equal to 0. So 0 is equal to x squared plus x minus 12. Oh, yeah, this is definitely factorable. All right, so x plus 4, x minus, that's a horrible 3. I need to slow down. All right, so take each factor, set it equal to 0. That's going to get me x equals negative 4. X minus 3 equals 0, so that's going to be x equals 3. So my x-intercepts are going to be negative 4, 0, and 3, 0. All right, so we've got the vertex, axis symmetry. Let's do some y-intercepts, which we're going to set x equal to 0. Let's see here, and I'm going to give myself just a little line here so I can demarcate where I'm doing my work. So y is equal to 0 squared plus 0 minus 12. So 0 squared is 0, 0, 12. All right, so my y-intercept is going to be 0, comma, negative 12. Right, because these two zeros are unimportant. So 0 minus 12 is going to be the negative 12. I will get to domain and range after I do my graph. So let me go ahead and put a little box around my y-intercept here. And now I'm going to take all of this lovely information and I am going to go ahead and graph it. Okay. So I've given myself this lovely grid here. Let's see. I'm actually going to start with the zeros because those are going to be the easiest to find. So negative 4, 0. And then it was 3, 0. All right. Y-intercept, 0, negative 12. All right. 0, negative 12. Okay. Axis of symmetry is x equals negative 1/2. So right between 0 and negative 1 is going to be negative 1/2. So instead of following the grid line, all right, I'm going to put this axis of symmetry right between 0 and negative 1, because that's where negative 1/2 would be. All right, there's my axis of symmetry. And then my vertex is at negative 1/2. So I'm already on the negative 1/2 here, and then negative 12.25. So here's negative 12, and then 0.25 is going to be basically a quarter of the way. It's super close to that negative 12, but not quite at half, right? So a quarter of the way. All right, anything else to graph? We've got the vertex, axis symmetry, zeros. Nope, we're all good. So let's see how well I can draw the curve that goes through that point, that vertex, that y-intercept. Ooh, that just got really bad. Hold on a second. Let's try that again. Make it a little curvier. Slightly better. All right, that works for me. And then the last pieces are going to be to find the domain. Domain for any of these quadratics, if they are opening up or down, it doesn't matter about that part because eventually, left and right, they are going to extend to infinity. So any x values can be put into the problem. As far as our range goes, we do have an absolute minimum here. So that's going to be a low value of negative 12.25 to infinity. And that is, really quickly, put some little green boxes around it to call it done. All right, and that is problem number 3 in its entirety. So that's going to be the end of this video. As always, please let me know if you have any questions or concerns, and I'll see you back in the next one.